All right, so welcome at the second Rholang office hours of this series. Last time we ended at actually we covered sending and receiving and the com events, and we ended with a kind of cliffhanger saying that this week we'll be looking at the persistent send and the persistent receive. And if I share my screen, I can share this one. Yes, you'll be able to see actually where we ended last time. Yeah, so this is where we ended last time. So I briefly touched upon persistent send and persistent receive, and then I asked actually you think about a novel use case where you want to either use a persistent send or persistent receive. So maybe, yeah, if you thought about it, that's good. And if you didn't think about it, then maybe we can come up with something right now. How does that sound?
Sounds good.
Yeah,
Okay.
I've been thinking about the persistent. Well, I've been thinking about the contract in terms of persistent receive.
Okay. Yeah. Because indeed the contract is a persistent receive, right?
Right, and the contract keyword is just syntactic sugar for a listening persistently on that name. Is
Yeah.
the way I think I understand that.
Yeah.
And have you noticed that sometimes when you, even though the contract is syntactic sugar, it makes more sense to think about it contracts than persistent receives often.
Yeah, and I think the reason why they made this the contract instead of persistent receive with the for comprehension is that in blockchains we usually like to think, oh, welcome somebody. I cannot really see who's this.
Adi.
Adi, hey, welcome.
Hey everyone.
So Adi, we just started where we ended last week with this slide, where I asked everybody to think about the use case where you would like to use a persistent send, a persistent receive, or both. And we were just thinking about the difference between a contract and the for comprehension. And Gary, yeah, indeed, contract sounds nicer. It just sounds nicer. It also sounds nicer to me. It looks more like a normal JavaScript-like or Solidity-like syntax, and I think that's the reason why they actually incorporated it. Maybe what is nice to do is to actually try to write something with the contract and something with for, and then find out to write something exactly the same. Would that be an idea? One with the for syntax and the other one with the contract syntax.
Sounds good.
Okay. So let's start with the for syntax, right? Because that's where we ended last time. So last time we saw this. You do like for, and then you put here like new variable and a persistent send. So last time we always did this, but the persistent send is with a smaller than equal. We're listening on the channel office hours, and then we're doing something. What are we doing? We send to standard out. Let's say a string. Cool. Office hours again. Like this. Okay. So looks good.
Sure.
Yeah. Okay. Let's run it.
Yeah, that looks good.
Oh wait, there's no output. Oh yeah. Why is there no output?
Oh, Right. We didn't write to office hours.
Yeah, exactly. So this is like only kind of contract, and then we also want to do some integration test.
I would do it after the last parentheses. Oh, you can't. Never mind. That's
No, you can't, because indeed office hours is bound to this code. Yeah.
Outside the
Okay, so we send to office hours, and as we saw last time, sending is by exclamation mark. Actually, it doesn't really matter what we send, so let's just send the base process, which is nil.
Let's do it again.
Yeah, let's run.
No, let's do it twice.
Twice. All right, fine. And then just for clarity, like we can just send anything. It's just the process of actually sending something. Yeah, see, we have twice office hours again.
Now, if you change that from the equal sign in the send and make it not persistent, see what?
Yeah. Okay. Yeah, that's fine. Let's do that. What do you expect here? Maybe Abby can answer, or Gary.
Oh, I think I know.
Tell me, please.
You'll only get one cool office hours again.
All right. And why would that be?
Because you're only going to listen there. It's only going to listen the first time.
Mm.
Or wait a minute. Let me think about that. Maybe you won't get any.
Yeah, good. Think about it, please. And just think out loud so we can follow your thought process. We learn from it.
So it's going to listen on it one time, and you're going to fire off one of those office hours, either nil or cool. And so it's going to get that, and then we're going to see one. We're going to see at least one cool office hours again, I think. And then the next time you try to send cool on the office hours channel, it's not going to be listening, I don't think.
Yes, exactly. So what is happening? Like I changed this. Like what you're saying is exactly correct. So we have a listen in here, and if we do a single listen, it means listen to this and then do the continuation. But in the continuation, like we're not defining any other listen. So actually just listen to it and then just stop listening. Only care about what is in the continuation. So indeed, once we either send this office hours or this, and again, like we don't know which we are going to send first because it's all concurrent, it's all happening at the same time. So we are sending one and then we're not listening anymore. So let's just send it. You're seeing indeed here, there's output call office hours again. And
oh, yeah.
Actually the variable, so this one got sent.
The second one got sent first.
Yeah. Well, let's just try it again because it should be completely random. Now cool again. And I'm not sure whether it is actually completely random in the current implementation, but it should be. Okay, it's not. Okay. Maybe somebody has to dive a bit deeper into the Scala implementation. Because since these are concurrent, it actually should not matter which one would be sent first. But
yeah, since this is running through JavaScript, it may be getting sequentialized, right? Is that?
No, it's not getting centralized, but it could there could be a bias.
No. Look, see, now it's nil. Yeah, we were so there is actually a random part.
Right.
Somehow, let's see if we run it again.
Yeah, but I think the probability of getting 14.
No, see, now I have nil again. Now I have cool. So I just very much bad luck, probably. Yeah. Okay, well, never mind. But it is non-deterministic which one gets sent first.
It's not guaranteed to be random, but it's non-deterministic.
Yeah. And I think in the ideal case, it actually should be, well, it is not non-deterministic, but it is the person creating the blocks. So in this is a standalone node, like this is being run against a standalone node, so there's no real blocks formation happening, but like in the how it will be, and how it's currently already being implemented on the testnet, is that as a user, you're sending your transaction to a validator, and the validator will include it in the block. And the validator actually is free to, well, since these are concurrent, it is both valid to implement this one or to implement this one. So in the end, it will be the validator's choice, aka the software of the validator, who will define whether he will include this or this. And he can put it random, he can do an alphabetical order, he can, I don't know, just always include line 7 first and then line 8. I don't care, but it's both valid. But he will define.
Okay, so if you change it back to an equal sign, then we get both again, right?
Yeah, exactly. Because that's why we started. We wanted to write this, but then writing it in the contract way. So let me
run this again just for the heck of it.
So let me just comment this out.
Run it again, because I would like to see this one be non-deterministic as well.
How do you mean?
Just run it.
Run it. Okay. Cool and Neil.
You got a cool first?
Yeah.
Cool and Neil. Neil and cool.
Okay.
Yeah. Okay.
That's almost random.
Okay.
Let's try now to make this exactly the same, but then write it in like the other syntax. Okay. So now we're going to define a contract. And help me a bit with the contract. Office hours, and in here I say new variable. Is this correct?
Well,
yeah, it is, I think. This I can copy literally. My Rholang might be a bit rusty because I haven't done it a lot this week, but I think this.
Yeah, it looks good.
Yeah. Yeah. So exactly the same is happening. So, well, actually, we can do it both. Just see. So we are defining now a contract, and both on office hours. And that's here just for clarity. We say this is the contract form, and then here we say this is the for comprehension.
you need a par, I think.
Oh, where?
A par between the for and the contract.
Yeah, exactly. Thanks. Yeah. Okay, so that's actually good. So what do we expect to happen here? Do we expect anything, or do we just don't know?
Either one could hear messages from either message being put on the office hours. We don't know which one will hear it, and we don't know whether they'll both hear the same one. No,
yeah.
Wait, they can't hear the same one, can they?
No.
Exactly. Yeah. Yeah. So I'm still expecting to see exactly like 2 outputs, and this can be cool first, nil first. This can be nil being listened by like this one by the for comprehension, or nil being listened by the contract. Like, just what is happening? We have like 2 unlimited listeners here, and they're both competing for the same resource, as we can say it. So there's like a race condition here, meaning that there's like a competition on the channel office hours, and like, well, we don't know what is going to happen here. It's like this is a race condition. Yeah, so this is the contract form, and this is also the contract form. Well, let me see. The contract form. Contact form. Contact form. Yeah. Okay. This is actually a very good question to ask to the office hours of Joshi or somebody else. To what degree actually the current implementation is completely non-deterministic, or whether it's kind of dependent on something else. Right? I would like to know. Yeah, so here we say this is the for comprehension. I would like to know as well, because it doesn't seem completely random to me.
Well, it seems to be taking the thing most recently defined more often.
Yeah, that's what I was noticing too.
Yeah.
So if if you put the contract first, it would probably find the for most of the time.
Yeah. But I mean, that's really interesting to find out. Like, both is valid. Like, if you have a bunch of COM events and you can choose 3 valid COM events, but by doing these 3 valid COM events, maybe you omit 2 other valid COM events, like, it's valid. You can make a choice. And as I said, the miner in the end will be the one making this choice, like the person making the blocks.
I don't know that they'll make it random on a single node ever. But
no, actually,
if we were listening from different places and calling from different places, it would be random.
Yeah.
On the network, pretty much.
Okay, but let me just make it a bit more complicated, because normally you won't see in office hour, like if you have a contract, usually you want to import a couple of other variables, right? Like, you don't just want to send 1 variable to this contract, but maybe you want to send 2 variables and do something with that. And let's try to come up with a nice use case, because I don't like all this mock-up code. Actually, I prefer to write something which you can use. What do you think? What is a nice example of a contract where we send 2 variables? Yeah, I know. Let's play a game. It's called is equal, and then send it out. We need, and here we're sending on is equal. Equal. We send variable 1, variable 2, and then we're sending out. We're sending. Variable 1, variable 2. Right, so that's like kind of game we can play, and later on, if we have a bit more time, we can actually print out whether these are equal, yes or no. But I think for now, what I would like to see is actually to implement this contract also in the for comprehension.
Rinka froze up.
Oh, okay. I thought I dropped off for a second. Yeah.
He'll probably reconnect in a second.
While we wait for him, I have a question that you guys might be able to answer.
Sure.
What part of the contract is the listening? Because we were talking earlier about how both the for and the contract are listening for something and then will output.
Okay.
Hey.
It's looking for you to write to the contract name.
I fell away, or
yeah, we lost you. We had your screen.
Okay, let me share the screen again. So is it fine like this?
Yeah, we see your Discord.
Okay, good. So where did you lose me?
I don't think you'd written the is equal yet. You just finished writing the contract.
Okay, good. Yeah, so I said, like, the purpose is to actually find out how to write this contract also in like the for comprehension, right? But just for now, see if we can have it at least in the correct way. This way. Oh, no. What's the problem?
Well, you used a.
You didn't asterisk.
You used a name in a process context.
Variable 1 at
Line
321.
3, position 21.
You have to do it like this? No, because it should be already a process.
Yeah.
Oh, let me see. Yeah, okay. You cannot send names then in an array. All right, that's fine. Okay. Any questions for this? What I've done here? Because then we go to implement the same thing in the for comprehension. And actually,
before we go on, Rinka, could Adi, could you ask your question again in this context? Your question was, what you say this contract is listening. Where is the listening in the contract?
Yeah, good question. Really good question. So this contract, indeed, it is listening. It is listening on the name is equal. And actually, well, you will see it in a better way if when we are going to code the for, because there it's really explicit. But it's listening on is equal, just as here we are sending on is equal, and there's a com event. So, well, it must be on is equal, and it's listening. It's actually doing some kind of pattern matching, and it's pattern matching two variables. Like, let's say, what do you expect will happen here?
It'll give us an error because it hasn't got two variables.
Okay.
It'll just call the contract called is equal that has no arguments.
Ah.
Yeah. Exactly. So what's happening here? You're actually seeing that. Well, there is some outputs. We are sending on x3 1, and we are listening on x3. But here you actually kind of see it already. We're listening for receiving two variables, whereas we're only sending one variable. So here there's no com event happening, because by putting these two variables here, you say actually only do the continuation, so only evoke the body of this contract if we're actually sending two variables. And since we're only sending one here, there's no match of pattern, so there's no two variables.
Now,
I think you might have dropped off again.
So there's no com event happening. If this will be a tuple space, oh, I'm really sorry. How is it now?
Yeah, it's good now.
Okay. Yeah, so I think like here we're actually not populating any tuple space, but in real life, like in RChain, we would just populate the tuple space being 1 send on is equal with 1, and 1 listen on is equal for pattern of two variables. And that will be it. So there's a send and receive in one channel, but they don't match, they don't come together because they're not sending and listening to the same pattern. So there's no com event.
so if
But this is really good. I mean, this is a super question, I think. And I hope that my explanation was good so you understand it.
Yeah, no, that makes sense. Thank you for that.
Yeah. And well, let's just see what you think is happening is if we do this like this.
shouldn't do anything.
Yeah. And why do you think so?
Because both of the sends, and you forgot the exclamation point.
Oh, yeah, very good, thanks.
Are only one variable. The pattern isn't matched.
Yeah,
now,
good.
if you were to listen for is equal with one variable, then it would do something.
Yeah, so let's just also do that, just to so you can actually see that we're not. Oh, here. I'll have a problem here. Yeah. Yeah. See. Okay. Very good. I think that was a good lesson. And here we just set here.
And on the contract line, you need.
Yeah. Now we're going to write this one in the for, and maybe actually I can give my screen to somebody else if somebody feels confident, and otherwise I'm completely fine doing it myself as well. So somebody else can just try to write this contract in the for-like way. Does somebody feel confident and wants to take over the screen, or should I do it?
I think Gary and I could do it. We don't.
Okay.
I think we can. Is anyone else want to take over?
No, we'll help along. So that's fine. If Jim, you can take over and just try your bit.
Share your screen, Jim, and you're muted. Jim, you're muted.
Why don't you put what you have in the chat? So I'm a lousy typist, and start with that. And
share your screen.
Yeah. I can find my screen.
If you go to Zoom, then you can press share screen. It's like down.
Yeah, I just had to find the window. Okay. I can go to here, I guess, and go to Testbird Chain, and what do we want to do? What do we want to do here? We want to do a quote, 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 eval.
We had this contract like is equal, right? And we were sending, listening for two variables.
Yeah, I guess I was on mute. I was asking you to copy it into the chat, so because I can't type. And I can't remember what it was either. R1, comma, R2, comma, STDOUT.
For 1 and for 2, like you don't need this.
What? Yeah, I don't remember what the contract was. Row dot IO. Row dot. Or is it row colon? It's row colon.
Yeah, the first. Yeah, exactly. Yeah.
It was right to begin with. S standard out. STD out. Backtick. Parentheses in. Oh, I need a new is equal also. Right.
Exactly. Yeah, perfect.
In, and then I have bracket.
Standard out is misspelled. And also, I don't think it's necessary to have to make var1 and var2 unforgeable names.
Yeah, that's correct. Although it's not completely wrong, of course, to define them. But
Okay, so which case am I supposed to do?
let me bring up quickly my screen, and then you can take over right away. Actually, I'll put it in the chat. Oh, can you stop it? Then I'll take my screen and put it in. Oh no, I actually can do it like this. Yeah. In the chat, you'll see the contract which I created before, and which is the task now to make it in a for comprehension. Oh, let's do the contract with receiving two variables. All right, variable 1 and variable 2. Yeah.
Did you put it in the chat again?
Yeah, because there we are only listing for one variable, but let's do it variable 1, variable 2. Yeah, so this one is the one which I made.
Okay, so so we want to do a now I'm getting confused. We want to do a for.
Mm-hmm.
And we want to do a
Yeah, so let's go back. Like we are in the normal like contracts, we are listening on the channel is equal, right? And in a for comprehension, how do you listen to name?
okay, let's
yeah, almost. Yeah, it's getting there.
now I don't need the parentheses, do I?
No, you don't need them. Exactly.
I wonder I would have to call it with extra parentheses. So then we have and then I need to call.
Yeah, there's one more syntax error right now. Maybe somebody else can spot it. And you also have to call it indeed.
Oh yeah, the equal sign goes.
Yeah. Yeah, so this is exactly the same as the contract which we wrote before. And indeed, you also have to call it.
So then I want to do an is equal right and the tuple 3, 3. Of course, we never tested. Is equal doesn't really do anything. We didn't test it.
That's correct. For the next lesson.
We have the end quote there. I mean, I could indent things better. But, we can try it.
Wait, do you have the exclamation mark? No, you do. Yeah.
Aha.
Oh, did you forget the exclamation mark?
Yeah.
I put a vertical bar instead of an exclamation point. I don't know how I did that.
Hmm.
They're on opposite sides of the keyboard. Oops. Okay.
Yeah. Okay, good job. That's actually really interesting what you have there. Like, can you elaborate a bit on what you're actually doing in this chat?
Yeah. Robot listens to various commands like eval, propose, deploy, and it's actually running on the master network. So it's not a standalone node.
Cool.
And it's running on our robot.net machine, which we manage collectively, cooperatively. And if it sees eval colon and code, it executes it. But also it supports 3 backticks and eval, which is more convenient for multi-line code.
Yeah, the 3 ticks are Discord code block delimiters.
Right. And then, you know, actually after the 3 digits, you're supposed to have the language. But since we have a Rholang command that does something different, we have eval here because it actually executes it. The robot.
That's very nice.
Executes it. So,
but it will work. It will actually compile if it has the 3 ticks or not. It just won't look as good if you don't use the 3 ticks.
Yeah, if you do eval colon and then put it in there, what it does is the main problem with that is it takes these back quotes out because the back quotes put it in block quote mode.
Right. Yeah, that is a problem with not using them.
So if I say, I mean, I can say eval colon and then say at hello. Whoops. Let me use a public name here for the heck of it. I don't know how long we'll be supporting those. You can do a persistent write of actually, let me see. I don't think it's defined. If we do a for message oops, I didn't want to do that. Cookie quote. I should do I guess I should do standard out, huh? Do std out row colon
Mr. Barcode.
Backward parentheses or Mr. Backward. In for message, read at public name cookie. You want to write the standard out. At message. I mean, star message.
Yeah, correct.
Okay, and then I can use multiple lines here if I hit Shift Enter, but I can just finish this off with a brace and a brace. Does that look good?
To me, it does.
Okay.
But there's no output, right? Because you're not sending on cookies only.
Okay, but now I'm going to do a eval colon.
Yeah, so you're propagating the tuple space right now with the listen, and it is being, you put a listen there, right? But there's no com event because you're not sending something.
Public name again.
Yeah.
Oops. We're going to do a persistent write this time.
Oh, you're sure you want to do that?
Yeah.
Okay.
I want a cookie.
I'm actually not sure what will happen here, Jim. I guess you know.
Well, I'm hoping it works. I mean,
but I mean, you're having.
I'm going to write forever. I want a cookie on the channel cookie.
Yeah. Oh, I see. Because you didn't do a persistent read.
There's one read outstanding.
Yeah. Okay. I thought there was a persistence read.
It's not a persistent. No.
Okay. Yeah. Okay. No, that's fine.
If I put an equal sign here, then I'd be in trouble. An equal sign there would have. This would have created a loop, and it would never return. Okay, so now I do a write. Now I can see that I wrote to the cookie, I want a cookie, and then it said I want a cookie, which was from up here where I'm reading it. So if I take this again, and I'm going to hit edit here so I get the back quotes. Yeah, back quotes aren't in the printed version. Cancel that. Now I listen again to the cookie channel, and it says I want a cookie. So as many times as I listen to it, it's going to say I want a cookie.
And that's because of this persistent send, right? Because that's indeed, that's very nice demonstration of persistent send. Yes. Okay, great.
It didn't matter that I listened to it before I wrote to it. It still did it.
Great. All right. Do you mind giving your screen share back to me? Because then I'll show one more thing. Good. So did somebody have like a question from to Jim maybe, or to what we've just seen? No? Okay, because I just make it quickly what we saw just now. one variable 2 is equal up, and then here we're doing cp add variable 1 2. Okay, so these two are exactly the same, right? Am I missing something here? Let's see if it works. So this, Jim, is just what you wrote just now. This, right?
That's a persistent read. Wait.
Yeah, yeah. So this is where we see if it works. Yeah. So this is where we, before we went to like the short walk around into the channel with the robot. There was these two syntaxes mean exactly the same. Like we persistent read, and we have the contract on is equal. One more thing, let's like, since we are like writing exactly the same, I can also write this. And I'll make these things here, and that's also again is exactly the same. And can somebody explain me why this with the add signs is exactly the same as this? And furthermore, why I need these stars at all, actually. That's maybe a question to start, and then afterwards we can think about why we can put an add there or a star there, why it's the same.
Yeah, this one is one that's a little bit confusing to me, and I think once I get this ironed out, I'm gonna not have so much trouble.
It's because they're both your quotes and non-quotes in the processes. So for the first time,
I'm not hearing that anymore.
Yeah, we're not hearing you. Your connection is bad.
Okay.
Why don't you continue, Gary?
Yeah, well, actually, I can, if the connection doesn't go back, because I think the explanation started in a good way. So the very first question is, why would we need this star at all? So why would we need to put stars here? That's because we are sending processes and receiving names.
Yeah, I think the important point here is that variable 1, just the word itself, doesn't necessarily have to be either a process or a name.
Yes.
If we just put the variable there all by itself, it's a process.
Yeah.
Okay, but so
no, if you just put a variable just by itself, it will be a name.
Oh, it's a name, right?
Yeah, exactly.
Okay, yeah, I got it. Getting it confused already. But when we put an @ sign in front of it, we're saying the name of variable 1, which means that variable 1 is a process.
Yes, correct. And then indeed, we have to send a process. So that's why we put a star here, because the star in front of a name means make a process out of this name. And well, since this is already a process, it actually will be invaded syntax if we try to put a star here.
Yeah,
maybe
that was a good explanation. It was this has been bothering me for a while, and that was very helpful. I'm glad you did that.
Okay, well that's good to hear. All right. Yeah, I think it's now 21:52. I wouldn't like to go into another subject and maybe leave that for another time. It was the join operator. I thought about actually doing that today, but yeah, since we only have 8 minutes, maybe it will be a bit too much to start into that, and we can just leave it open for just a discussion with all of us, or think about something. I'm up for anything, but I wouldn't like to introduce a new syntax or a new something else. Let's do that for the next week, the join operator.
Yeah, I haven't looked at the join
And then,
operator at all.
Okay, you haven't looked at that. Well, it's basically just to give you a small peek in the for, like what we're doing here. We are listening on is equal, but what you actually can also do, you can listen on is, well, let's say is not equal. And if we do that, we also have to define it here. And actually, now I'm just anyways showing it. And here, well, let's also variable 3 4. So actually what we're doing here, we're listening on 2 names, and if and only if there's actually a message being sent to 2 names, then the continuation will trigger. And that is the join operator. We're joining. We're actually joined. We're listening on 2 channels, and if there's message being sent to both of these 2 channels, and also if both of these messages contain of 2 variables, then there will be a continuation. So,
okay. Do you have time for a question here?
Of course, yeah, for sure.
Okay, in the case where the contract is equivalent to a persistent listen on a persistent for, or what? Wait a minute. We say a persistent listen is what it is. Okay.
A contract is the same as the persistent listen. Yeah.
Now that you're using the join operator, does what we're doing now have an equivalent contract?
It's a good question, and actually, I wanted before this office hours to look into that. I don't have an answer at this moment, but if you keep the question for next week, then I will have an answer for that.
Okay.
Yeah. But that's a very good question. I'm wondering too. So maybe try to figure it out yourself next week, and if you have a finding, then you can explain, and if not, I will explain.
I've got a theory that if you do this, it would be the equivalent of doing 2 contracts. But then how do you make sure?
When I'm thinking about it, I think about that you should do a nested contract.
Aha.
So you do a contract, and inside this contract you define another contract.
Very.
I think that will be the equivalence, but then you see that actually a syntactic sugar is not so much syntactic sugar anymore, because well, to me this looks is better than a nested contract. But I will look into that next week. Yeah. Okay. That's very good. So next week we do the join operator, and we're also going to look at the contract again. What will be the syntax for that, and maybe something more.
If there's no more questions, I'd like to continue with the robot a little.
I have one quick question just before we move on. The vertical bar, what does that actually do? Does it just mark the end of a for or a contract?
No, that's a very good question, actually, and I'm happy you asked it. So let me share my screen again and just do a very simple. We're just listening for up. We can throw it away. STD out. No, sorry. Is equal. Then put test, and here we are sending on STD out. I'm here, and listen again. Now we have indeed the vertical bar here, and here we're sending on test. We're sending a nil process, like the, yeah, we can send anything. It doesn't matter. Hello. And then your question is, what does the vertical bar mean, right?
Yeah.
Yeah, so vertical bar is a really fundamental operator in the Rholang, and it again is really good you ask it. Vertical bar means do it concurrent, do it at the same time. So here, since we are at the same time both listening and sending, that means that we do the continuation. If we wouldn't do it at the same time, then there is no communication happening. So it's not concurrently sending and receiving. So there's no COM event. And also, yeah, well, if we would omit this, that is also invaded syntax. Because after each process, if you want to join a couple of processes after each other, they have to be in a concurrent way.
Sweet.
Yeah. Good. Yeah, that was a very good question. And also, let's next week, let's also do the join operator to start with, and then afterwards we can also do things in a sequential way, because if you are familiar with other programming language, and I assume so, then you probably want to know how you can do things one after each other, because Rholang is inherently concurrent. It's very nice that we can always do these things all at the same time. But sometimes you just want to do something after something else and only do it after something else. So how to do sequential processes. That's also possible, but we have to do a small workaround. I would say for next hours, just for next week, just try to go over Learn Rholang by on the RChain CoLab website is really good. I think until now we covered till here. So the first 4 chapters, and try to get on, and then next week we do the join operator. And with that, I think we reached 1 hour. But I'm available for more questions if there's more, and yeah, probably the other guys as well. Thanks for today. I really enjoyed it, and also with the interactions, that was really good.
Yeah, it's very good. Thank you, Rinka.
Thank you, Ringo.
Okay, glad. And reach out to me on the well, both the Discord channels.
Yes.
If you have some questions.
Saying something?
Sorry?
I think Jim Scar's trying to say something.
Yeah, I'm still on mute. Yeah, I just wanted to show here that we can deploy this to the master network, and we can propose a block, and now forever, cookie will always return, I want a cookie across the master network. Uh-oh, what happened?
So what you're saying is that on my machine, if I should do a cookie, it should do.
If you're connected to a master bootstrap, yes, but the proposed failed here. So I probably have to restart the node. Probably, I don't know what the error is. We look at the log here, we might get more information. No, we don't. Okay, that was all I
And Jim, you will put it on YouTube, right? This
yes,
this series, right? Okay, that's good.
Very good. Thank you so much.
Thank you also for your demonstration and working together.
All right, awesome.
Okay, goodbye.
Bye-bye.